All right, so this morning's first topic is how to blend the idea of container affinity, anti-affinity pattern. Does the speaker want to walk through this now?
Yeah, hi, Chris here. Okay, so last week, I think that Victor put the question under the topology manager pod level resource alignment. So the question was, is it possible to combine the proposal from Alexander's presentation with this enhancement, especially with pod versus container level alignment? Can we configure this preference in the pod spec? It's hard right now understand how it can be combined because the proposal from Intel guys lacks of the changes that will be in the topology manager and other managers. So that's why I asked on the Slack about when the presentation would be and how to combine that. Maybe similar idea would be with the annotations, like Alexander presented in his demo, where containers are collocated on the same NUMA node or dislocated on different NUMA nodes based on the annotations as presented on the example. So maybe anyone has a good idea how it can be achieved in a good way or anything like that.
Yeah,
yeah, go ahead.
I apologize. So I know many of us in the US are getting out of a holiday weekend stupor. So I was not personally thinking about Kubernetes this much over the weekend to have come up with a brilliant idea here yet. I don't know if others had. I guess what I'm curious is when you say it wouldn't work with other managers, which challenges do you see that maybe others hadn't seen?
Okay, because we wanted to give the pod topology manager scope defined as the flag, and also the proposal from Intel guys that will give the new algorithm. It mentions that it will require the changes of the topology manager here. So I was thinking what changes those are, and that's why I wanted to see their proposal more briefly. And if we wanted to move the topology manager scope to the scope of the policy to the pod spec, maybe it won't be the problem, the changes in the topology manager, but yeah, that was my thinking behind getting the details.
Chris, I think you're probably mixing two independent topics with that. So probably the pull request, what you're talking about with improvements of algorithm for topology manager, it's nothing related to like within pod or within container. It's more about like how devices will be chosen by the topology manager, or actually how any resource will be chosen by the topology manager. And this annotation part, what is written example here, it's more about this is actually for topology manager to decide the affinity of the resources between the containers within pod or the whole within the whole node. So consumer for those annotations might be a topology manager, but probably it will alter the mechanism of it will be not an admit container, but the whole admit pod. And well, frankly speaking, I'm not ready to fully answer this question, like how it will be affecting the topology manager, but it's two separate problems, what I was trying to say.
Okay, thanks for getting that. I get it now, because I was, as you said, I had a mix up how your algorithm is connected with the demo you presented last time, and And yeah, that's why I wanted also to know more details.
So with annotations for us, it's like with the demo what I shown. For us, it's consumed in this CRI resource manager because we have independent events. We have create pod or create sandbox in terms of CRI APIs, and we have a create container. So every time when we do when we get create container API call, we can look at the annotation and see if we need to find the affinity or anti-affinity of resources. So from the multiple selection of equal resource types, we with affinity and anti-affinity just increases or drops the score, which one will be preferred.
All right. All right, I think I have to go with this through in slow time.
Yeah, well, I mean, okay. Try to explain with more simple use case. So
okay.
when you're saying I have a pod and I have a containers like 2 containers for data plane. And both of them will do the APC using the shared memory. So in this scenario, you want to have a CPU cores close together because of L3 cache, which might be used. And then you want to have a memory controllers to be close together. That's why you define, you say affinity container 1 to container 2. And when we will, when the CRI resource manager will see, okay, those 2 containers needs to be aligned, so we will come up with closed CPUs, closed memory nodes together.
Okay, I get it. So, do you think this somehow similar idea could be applied to the scope in a pod spec or any other idea? Because some time ago we came with topology policy per pod that was specified as the topology policy field, and I was maybe thinking there might be something like topology and in the topology field, and in the topology field maybe the scope field or something like that. I wanted to ask for ideas here.
Well, my idea, at least why I presented it, it was about to use the same pattern of affinity and anti-affinity. Because right now this pattern is used for like the bigger scope where you can do this node selection, saying like this pod should be affinity to, let's say, like database and I don't know, like front-end API or backend API for which using with database needs to be collocated together. The same scenario I was thinking about to extend the pod spec with similar fields, but which will be consumed within the node, within the kubelet or something similar. So it will be similar pattern saying what preferred during execution or required during the execution, and then the same structure of operator where you can say match by the container name or match by the label name or match by some other attribute. So this annotation, which is copied right now in the meeting minutes, it's the most simplest case. Just matching the name.
All right.
Give me a second. I'll probably try to find an example of like more sophisticated example of label matching.
So the question is here that going with the affinity and anti-affinity would be desired here.
At least I would propose to do it just to keep the pattern. Yeah, so. If I can share a screen, I can show a more sophisticated example of affinity, anti-affinity. Derek, can you make me a co-host so I can share?
Yeah. You should have the option now.
Mm-hmm. Yeah, so in our documentation, we have this more advanced syntax where we can say what we have key, like operator, and when matching the values, like similar what currently is done for pod affinity and anti-affinity on the cluster level. And so we have this support of operators like equal, not equal, in, exist, not exist. So like we can match the labels of the containers. And then we can say like, put me close to the database or put me far away from the data plane, something like that for the containers.
Yeah, right. So it seems that it is more configurable way rather than the scope, because you have more control
Yes.
here. But yeah, but it is more granular. I mean, more management is required.
More management. Well, it allows users to specify what actually he wants.
Right, Francesco. My question was if more desired way to give the scope of the policy, it will be if we would to do this scope in the pod spec, what would be the desired way? If it would be the affinity anti-affinity way or any other way? Because if you want to do this in like the flag, this is the way we proposed. And
yeah, so you're asking if you, in order to cast this as a anti-affinity problem, if you want to put it that way, it would be the way you'd say that you wanted pod level affinity would be that every container had to be affinitized to every other container on the dimension of NUMA or whatever. Is that the idea?
Yeah, this is the idea, but maybe anyone has another idea. I'm actually asking for ideas here.
Sure, I was just trying to understand what your kind of notation here was.
Right.
In the box, yeah.
Okay, so maybe I can come back with that on the Slack and ask the question. Maybe someone will come with something. The other thing that I wanted to talk about is that last time I think that Derek said what could be a better default scope, if maybe the pod will be the default scope or the container. And I thought that the container by container basis, so the container scope is the default right now, because this is the normal behavior right now. So if we would change that in the future as the pod will be the default, it won't be the backward compatible for users. It won't be the user experience best way. But maybe this is something to discuss later if there would be some solution.
Yeah, I think rhetorically my question is more if we hadn't done container scope first and we did pod scope first, or we did both at the same time, do we think more users on this forum would desire pod versus container scope? Like there's the default as in what the kubelet default is, and then there's the which will actually get more use and traction from the audiences that are concerned about the capability. And I'm curious if more folks see their use cases aligning with pod versus container scope.
Okay, I understand now.
So in the case here where you guys are presenting pod, do you actually see yourselves as users of the container scope, or do you think you will always use the pod scope? And then what is the use case that you're targeting where you think that recommendation makes the most sense?
Okay, so in my opinion, the container, as I said, container by container, the container scope will be the basis. But our target here is, as we mentioned before, is the 5G workflow. It is one of the use cases for that we see. But as you can see on the PR, the BG described there the whole 5G workflow requirement in one of the PR's comments. And this is actually the desire, our desire for the pod scope here.
Yeah, and I guess what I'm curious about is are you saying in your view, a 5G deployment of Kubernetes would always configure their node to use this? Or do you think a 5G deployment of Kubernetes would, given 3 nodes, deploy 1 or 2 of the nodes with this option?
Actually, it's hard for me to answer that question because I don't have the deep view into the 5G deployment.
Sorry, could I interrupt? I think that it will be only a limited number of nodes that will use pod level alignment, because these nodes are UPF nodes, user plane functions that are designated for, as we said before, high performance packet processing. So yes, it will be only a limited number of nodes that will use pod level affinity.
Because when it gets to that, the kind of tension I guess we're all trying to learn on this together is the overhead of declaring your desired affinities on the pod itself, or mapping your workloads to particular node pools that auto apply the right affinity. And so that I think if what you said proves true, I think that's the type of useful feedback I think we would all like to see, because it could end up being that it's potentially simpler to do what is desired by getting it in the kubelet versus putting in the pod spec. But still want to think through that.
I think part of the problem is that a lot of these 5G deployments don't have a whole lot of physical nodes. So to have granularity at the node level or node pool level might be a bit unrealistic, just because of there aren't many physical nodes in a deployment.
Yeah, that was kind of the other question I was going to have, which is like, there's 5G running in some central core in some city, and then there's 5G running at like the far edge of
Exactly.
a small pole in some small part of the country where you could be running 3 nodes versus a couple hundred nodes. And so for getting to one size fits all outcome is sometimes difficult for sure. I agree, Jay.
Yeah, I was just going to throw in NVIDIA's kind of use case for this stuff, where we really are in the mode of we assume that we have big server machines with lots of GPUs, lots of CPUs, and we can totally just dedicate a set of nodes with a per node policy, ship, jobs to that node that make sense for alignment in one policy, and jobs to another node that need alignment in a different policy. We don't have to have as much granularity where, oh, this pod is going to be aligned like this other pod is going to be aligned like this, because the minute you do that, you actually have a whole set of other problems that we haven't really talked about here in terms of fragmentation of resources, because suddenly now they're allocated across different constraints that you weren't able to control unless you had some sort of admission policy on what jobs were able to land where. And then answering the question about pod level versus container level, I think most of the jobs, at least the ones that we tend to run on GPUs, there's only really one app container in the pod anyway. So whether it's container or pod level doesn't really matter. It would end up being the same at the end of the day anyway.
The only exception to that I would say that I see commonly would be sidecar containers running proxies. So being able to control those particular containers in a different affinity fashion than the others might be useful.
And I would like to throw more use case. So the reason why we thought about with container affinity and anti-affinity, and why we actually implemented this big scope of operators, is what we have a scenario like the customer runs the data center, and we have training AI jobs which is running during the night time. And we have medium priority workloads, which can be a bit slowed down because of those AI jobs. And we had the high priority jobs, which shouldn't be slowed down. So like with affinity, anti-affinity scenario, you can say anti-affinity to high priority of the jobs. So it never be close to enough resources, so we will not create the noisy neighbor problem. And obviously like affinity to medium priority jobs, so we can affect or slow down those jobs. So it's not really like pod or container, it's more like every single container which runs within one node.
And then for that use case, Alex, were you did you author some type of webhook to institute that policy and tie it to like pod priority?
Well, it was just anti-affinity to high priority label of a pod.
Okay.
So
I was
like,
trying to think like
every high priority.
Yeah, I was just trying to think pods have a priority field now, so I didn't know if what you had discussed was basically tying either something in the pod spec to that field or having
we can do
CRI resource management now.
Well, we can do a bunch of things. For example, like we can prioritize based on the namespace. So we can say like, don't put this container close to a kube system namespace. It's also possible.
Yeah. So I feel like this is there's probably no use case that can't be satisfied by the type of affinity, anti-affinity semantics you've expressed, Alex, except similar to pod affinity and anti-affinity, it becomes really hard for people to understand. Like when I think about kube itself, I find a lot of the topologically aware scheduling things to be confusing for users in practice, but they are very expressive. And that expressiveness I like. I could see how you could build a lot of interesting things, but I can also see how
that's why we come up with that short notation when the user can say like, okay, I have a container, I have I have a pod, I have 3 containers in this pod, and I know they must run together. So you just say the notation affinity with 3 containers together. That's it.
Yeah. Yeah, I think it's fair to say though that a lot of people get confused on the cluster-wide scheduling affinity, anti-affinity concepts in practice. Maybe not the authors on this call, but practitioners, I know definitely seem to get confused. But I can see how for a use case like Kevin's, it's kind of not a must-have, but it would actually be easier for him to just have a dedicated node pool. And then if Cesari's comment was accurate, I could see that as well. I
It's
still
also
think
more
there's the core tension, Alex, for your use case. The affinity, anti-affinity constructs, there was still no guaranteed scheduling of that pod to that host by the cluster-wide scheduler. So you still had the bouncing problem with that proposal. And we still have the bouncing problem with all of these proposals, correct? So if we try to think about dimensions to measure them against, the node level visibility problem is at the cluster levels is still largely unsolved and for the moment ignored, maybe for good reason. And then it really just comes down to the user experience of dedicated node pools versus general purpose expressiveness. Do people see other dimensions right now that we've discussed that we'd want to call out on why one approach or the other one might be preferred? Okay.
Well, actually, Derek, I don't really understand your comment about with bounciness.
About which?
bouncing.
About bouncing.
Well, everyone seems upset today that with the fact that the scheduler could schedule a pod to a kubelet and then the kubelet will reject that pod in admission, right? And
well, it's a question of what we want to say. Is it really reject or is it a problem with particular container? Because rejection or this kind of error can happen not only because of topology errors. It might be because like one particular volume storage might not be attached to this. So node is healthy, all the resources are available, but something happened during the attachment of the storage and the pod is failed. So we need to have a way to a scheduler to return the answer saying like this particular pod is problematic, we cannot run it. And what is the reason for that? Will it be topology or some other failures? It's a different story.
yeah, so I've always...
I would agree with that. I don't necessarily think that the scheduler not having enough information about these dimensions in order to make, like a up-down decision is necessarily the same problem trying to be solved with this particular like support pod level resource alignment cap.
Yeah, I guess what I think about on this, Jay, was like, I've always imagined Kubernetes as traditionally being either one, an elastic system where if a pod can't be scheduled, we just go create a new node on demand because we're running in some cloud, or it's some system that has, that in my mind looks more like a traditional 5G deployment in a city, which is like I have a couple hundred nodes, maybe some excess capacity. And if I bounce from one node to the other one, like if the probability error of a scheduler placing a pod on a node that the node ultimately rejects it is like 2 or 3%, like big deal. Like it'll just get put on another node and stick there for the next month.
Right, but if it's if it gets to a node
or a 5-node cluster, then people want to get way more efficient uses of that 3 or 5 node cluster. And so I'm mostly just trying to think through.
Or if it gets retried just all the time, just going from one node to another. Yeah.
But again, it's another problem what we sooner or later we need to solve. So right now with topology manager and all other resource managers, we are dealing only when the pod or container is created. So we cannot react dynamically to running workloads. What we prototype it is actually we do rebalancing. So if we cannot fit, we can move some of low priority workloads to another area so we can still fit.
Yeah, so I always just struggle with that one though, because it's like if I have a 3 or 5 node cluster, do I actually have low priority workloads? Or are they all running a telephone call, right? Like,
well, you have a bunch of sidecars with all these kind of proxies which consume resources defining, but you can easily identify them and move it around, or like best effort class.
yeah.
Sure, but you can't move the sidecar and
No, you
not
can
think
you can
sidecaring
you
for,
cannot
right?
you cannot move it out of the node, but within node you can move it to another CPU set. You can move it to another
Right,
memory region.
another, yeah, gotcha.
That's what I'm thinking. Like if we got a new container which requires like strict constraint of resources and we cannot fit it, so we can shuffle our workloads to actually fit it within one node.
Yeah, we actually have a different approach at NVIDIA where we can avoid the bouncing altogether because we, again, have so many nodes that we can choose from. We just we constrain the shape of a job, and we know that, you know, it's only ever going to ask for this many CPUs or this many GPUs, and we can make sure it lands on a node that's dedicated to, for example, only serving jobs that have 2 GPUs on them. And because we know a GPU has, or a machine has 8 total, because we only put 2 GPU-sized jobs on that node, we know that they'll all fit by the time they land there. There'll never be a situation where you ask for too many and it won't be able to, you know, resolve its constraints because it only can get this many CPUs and this many GPUs, and we know there's enough based on that constrained shape of the job that it will always be able to land there.
Right, it's a finite resource tracking on those things, right? But
again,
does that mean you don't support best effort QoS class?
Not in our internal clusters, no.
Gotcha.
We just assume there's enough capacity to be able to schedule these jobs, and if there's not, it gets queued up until there is something.
But is it over provisioning, or it is some kind of smart?
It's the opposite. It's underutilizing the available resources.
Yeah, it's potentially underutilizing things because, you know, imagine you have a job that's dedicated to only running 1 GPU sized jobs, and a 2 GPU job comes along, it can't land on that node. It has to sit in the queue because that job can only run 1 GPU sized jobs.
Okay, I see.
Yeah. But again, it assumes you have lots of nodes and you're okay with a little bit of delay because you're doing something like, you know, machine learning training. And it's okay if it takes a little bit longer because it's this really long running job anyway that just needs to be batched up and run to completion at some point. So it kind of goes back to what Derek was saying before about, you know, there's different use cases based on how you imagine your cluster being used and the type of jobs that can land there.
Yeah. So I know we also want to do the memory manager update discussion.
So yes, I can give a brief update. It will be not as interesting as this discussion, I believe, but
before we go on, so do we have some general agreement about the KEP in question, 1752? With regards to like the whole pod container scope flag? Sorry to interrupt you.
No, I mean, I think it's a good question. You know, I don't want it to just sit here stalled because, you know, lack of comments. If there's people that are, you know, very opposed to it, we should know that. But I feel like they would have spoken up by now. I feel like, yes, these are all interesting discussions, but yeah, we need to be able to decide if we move forward on it or not at the end of the day. Right.
Yeah, I mean, I'll put this as a comment in there, but I personally feel like it's a good trade-off between sort of usability and the fine-grainedness. So, or at least the CLI flag is, you know, just a container or pod scope to set the default of how the affinity constraints are applied.
Yeah. So for myself, like I think if I think through the enhancements that we've discussed, I think Kevin, your preferred hints on devices, I was generally fine with, and it seemed like a good incremental update. For pod level resource alignment, where I struggle on this is just wanting to make sure, like, this is also a good incremental enhancement. What I wanted to know is if we had the moment to sit there and say, was anybody swayed by Alex's presentation to say, oh, this is where I want to get my our collective development energies behind. Then I just wanted us to have that conversation. Like right now, like there's two questions in my head, right? There's one, like, what do we do next? And then two, like, who is actually here in the community to do it? And if we, the preferred outcome I would have is that we like all align on the same end state so that our engineering energies can all go together. And right now it seemed like in some ways we're kind of fragmented, and maybe that was my own incorrect perception, but considering we had a presentation from Alex saying, I think Cube should stop doing half of this stuff, it felt like a large voice from Intel was basically saying, there be dragons, essentially. Am I reading the room wrong here?
A bit wrong. No, we just, well, the point of my presentation was what we can have generic algorithms which will serve extensively various use cases, like from the very restricted environments like 5G network stuff to the scenarios where you have like very complex like user space, like database plus something applications, or just generic optimization related to NUMA and something like we tried it with different applications. The question is like what we do next, like, and what we do next, as you said, we really have multiple options. Like one option is how we expose that into a pod spec. Like, should we try something with annotation internally and then evolve it into the pod spec fields, or we can target it right now? When we have a lot bigger question of should we actually do it in the kubelet? Like, should we really need to make kubelet as a huge monolith which will be taken into account the hardware specifics? Or we can push it somewhere, like for example, to runtime, so like where CRI and containerd will have like possibility to innovate and like extend the scenarios. So like, for example, like in containerd, you can have a multiple plugin. So if you have a node where you have, I don't know, like with hardware constrained scenarios, you can enable plugin and it will do the magic behind the scenes without kubelet knowing, like one of the examples. Or maybe something else, like even like with the current scenario of topology manager plus CPU manager plus proposed memory manager, we can have all those entities separate, or we can have a combined CPU manager plus memory manager, which will do again more clever algorithms how to align those to like native resources. So I would actually thinking, but sorry, I don't have like a straight picture in my mind yet to propose it very carefully, but the overall idea is what I would suggest we come up with a list of potential alternatives, like how we can implement all of these things, and then like write down pros and cons for each of these solutions, and when we decide where we go.
Yeah, so that's why I was trying to tackle on which domain are you going to deploy in with this solution, right? So I think, Kevin, you've been clear on maybe the data center topology you're working within at NVIDIA that is helpful. I still feel a little fuzzy on variations of 5G deployments here, where I don't think we have consensus on a view, really in my mind, particularly between like the difference between 5G at smaller constrained node resources versus just a larger traditional data center deployment. And the fear I have a lot of this stuff is, and I please don't take this wrong, I mean this in the nicest way possible. A lot of times I think some of the information we put out as a community is contradictory. And it's like you had to make some choice to make one workload, one thing run optimally, but then you can't do a deployment because you're asked to also make another choice that does something in the opposite direction. And then you just kind of end up with like a frustrated user. And so depending on which voice any one of us are representing on this call or in this forum, or as we like evaluate an issue, I sometimes worry that like, unless we are prescriptive on saying, this is the domain and this is the recommended configuration for the kubelet, and we're very clear on it, then we're just gonna end up with a bunch of unhappy users. So what I would really love to see from all these proposals is like someone assertively say like, I recommend when you're running this particular type of CNF function and this type of 5G deployment, you always configure the kubelet with this profile. And like, as a body of knowledge in the community, we can all say, yeah, I agree with that. That makes sense and is the latest state of the art for where we're at. Or in the NVIDIA use case, if you have excess capacity and you're running multiple GPUs and yada, 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 I'd see these things going. Like, I want to see more of our recommendations tied to actual domains of practice and not like theoretical.
I mean, it sounds like you're asking for, you know, better documentation and best practices guides as part of this sort of ongoing increasing complexity on.
Right, otherwise it's contradictory, right? Like
I agree. I completely agree.
When I ask like, who is ever going to run the container policy if you have the pod policy, it's like, seriously, should we deprecate container policy? Because 18 months from now, whoever is still sitting around is going to be thinking, what do these two things do and when and how would I use them? And so I really want to know, like, it sounded like from NVIDIA, it's like, well, most of my apps are just singleton app containers inside a pod spec anyway, so I don't really seem too concerned. And so then part of me is like, well, should we just have a pod policy? Like, what is the use case motivating keeping the container policy around? And that's where I struggle a lot of this, is we just keep adding new branches, but not necessarily pruning or being precise on when and how to use each. And so that's where I still am on this. And I would love to see, like, maybe I'm wrong, but for this particular proposal, I haven't heard like a strong, this will never work for me if we always ran pod because XYZ. It's like, it really won't matter. Right, that's what I heard.
Sorry to interrupt. Actually, for 5G, you might have with scenario. So, like you have a pod and you have a DPDK application, and when you have some support container saying like logger or something, you really don't want to have those close together. So you don't
right.
really.
Well, Derek's just asking that we get better, you know, sort of best practices and guidance in the documentation around all of these different sort of flavors of workloads and how to configure kubelet and the topology manager and all the device plugins in a way that's optimal for that particular workload without making users' heads go poof. So, and I agree with that because it's very complex.
So in this specific case, I think the reason that the topology manager even kind of defaulted to having container level scope to start with is because that's how the CPU manager was designed. And even then, the CPU manager doesn't really have a whole lot of, I think, motivation as to why they did it on a container scope versus pod scope. Because from what I understand, most of the use cases for CPU manager aligning on just CPUs alone is specifically for these, HPC style apps, which are, again, just going to be a single container per app. Seems like Alexander's shaking his head.
Yes, I'm shaking my hand because the CPU manager was implemented primarily because of this network functionality. So again, it's DPTK application. It's application which requests exclusive core. Each runs with 100% with CPU load busy loop because it's polling the PCI device. So that's why the CPU manager was mostly thinking about only guaranteed class, only exclusive allocation, only one container.
But
So I guess
again,
my question is
only one container though is the kind of the same style. Yep. Go ahead.
Alex, I think I've read a great white paper from Intel. It was like 100 pages describing the performance benefits of topology manager and CPU manager. What I'm curious is, would the next revision of that white paper change the recommended configuration to be container versus pod scope?
Well, we are, at least my group is currently, we are looking at the whole node scope. Because as I give a reference, what like we have a devices, we have a workloads which is like higher priority, we one which have a low priority. Like one of the examples also with AVX512 mitigation. So like if you end up in the node scenario, what like some of the workloads starts to use the heavy AVX instruction set, and they started to throttle the base frequency of the cores, you want to isolate those kind of applications out of any others. So you need to dynamically react, otherwise like you know, not consistent performance out of your node. So for me, it's not pod or container. It's more about like the whole system, what is going on.
What I'm hearing is a third iteration of that white paper will say not to use any of this stuff.
Well,
and we have like
more like this affinity, anti-affinity pattern. What?
We have millions and millions of dollars of engineering minds here sitting together trying to find an outcome, and that's the type of thing that drives me insane. Then, right? Because the more we add, then the more we need to support, and the harder it becomes to grow people here. But for the core question, Jay, though, for where I'm at right now, like I'm not hearing why I wouldn't just run pod moving forward. And if I imagine the majority of user recommendations on this proposal would say just run with PodScope. And
I don't necessarily disagree with that, but if you're asking whether we should deprecate the default container-based scope, I would hold off on that.
yeah, I'm not saying to deprecate it, but I'm more just like, is it one of those flags that's never used in practice then? Like, am I really?
It'll probably, be used in practice by some very, very specific use cases in the 5G area, but other than that, probably not. So anything from a configuration or configurability perspective and user experience perspective that will hide that level of granularity in a way that's, makes it easier to use while giving the flexibility to those 5G deployers that are configuring this kind of stuff at that level of granularity, I would side with that type of solution. But
I guess in, kind of by default, it's also going to be used by the don't cares that have, a single app container per pod, because if that's the default, they're going to use the container scope, even though the
right.
pods
The problem is that a lot of those single containers per pod are actually two containers, because they'll either have an init or some sort of sidecar container that's doing either really high priority work or really low priority work, and that's part, you know, like one being like a logging setup type thing, and the other being more of a routing proxy. So
Yeah,
Yeah,
I know in our setup we have an init container that pulls in all of the, basically requests the exact same set of resources that our app container will ultimately request, so that it can do some sort of prerequisite check to make sure that it actually got what it was supposed to. And if it doesn't, kills the container. It doesn't happen in practice, but we want that extra level of check there before it actually starts the app container. And then we also have a logging sidecar that sits there and runs alongside it. But for that one, we don't even ask for guaranteed CPUs or anything on that. It's just there doing logging. I guess in theory, you could get a bit more performance out of it, but we don't actually care what alignment that guy has, at least
Well,
currently.
CPU is a cheap resource. The most expensive resource is the memory. So if you have two containers which communicates or transfers a lot of data between each other using like APC or any, well, even like a kernel socket, when you want to have them aligned on at least on the memory controller.
Yeah, that's fair.
Okay. So we have 6 more minutes and we had another topic. We could pick this topic up this afternoon. I haven't looked to see what the SIG Node agenda is.
I think I can just spend these 5 minutes to summarize. Could you give me a co-host so that I can share? Okay, could you see my screen? Yeah.
Yes.
Okay. So this will be just a brief summary of recent update on Memory Manager. So first, we, as Jay suggested, we eliminated the negative connotation and changed everything to multi-NUMA node name. Then we just follow the design that Kevin's proposed. So there is also explanation provided by Kevin to this discussion. You can watch it at the following Slack link. And here's some code snippet. Yeah, that's right. And the next point was about the number of the flags, because there was a concern that user experience can suffer from let's say extensive. There are only 2 additional flags in Memory Manager, and the first one is in fact provided to keep backwards compatibility with node allocatable feature. So in fact, my question is if in fact admins indeed employ this feature in when they are using Kubernetes. So if not, we can forget about this flag. Just
when you say node allocatable, you mean just doing system reserved and cube reserved?
yeah, exactly.
I think every major deployer of Kubernetes sets a reservation. There's actually an interesting Medium article I found the other day that described the heuristic differences between the various cloud vendors on how they apply it. But I'd be hard pressed to find anybody that is not setting a reservation. I think it's very uncommon to set system and cube reserved versus just setting system.
Okay.
And I think the reason we had the 2 flags is we wanted to separately budget or place the kubelet and the runtime in a different C group than the rest. I don't think anybody in the world has actually done that. And so just having 1 flag is probably what you're seeing more commonly used.
We only use system as a point of reference.
Okay, so the answer is yes. So we have to let's say.
So my question is, what's the difference between pre-reserved and reserved? Like, could you just call the flag reserved memory zone?
Reserved is because okay, note I give you a background because okay, note allocatable feature was developed before to increase the stability of node, and for this feature, as Derek said, we specify two flags: system reserved and kubelet reserved, so that we can reserve, for example, memory for system and kubelet daemons.
No, I completely understand that. I'm just saying the name of the flag. Couldn't you just call it reserved memory zone? That's not going to conflict with any existing flags, right?
In general, it's possible. It's no real reason why it pre-reserved. It just was the name from the beginning, and so just we stick with it. But in general, again, just give you possibility to reserve some amount of memory if it's few pages or regular memory on some specific NUMA node. So.
Okay, so I will move forward, okay, because
I have a question about the multi-NUMA groups flag. So can we come up with something more user-friendly on this? Because especially like on the cluster with a lot of nodes, it would be hard, for example, for admins to actually like go over all the nodes and set it up. So is it possible to somehow like define them like on the start of kubelet automatically?
Yeah, in fact, in the list of the points, what alternatives we have, I thought about some default value for this flag, but then we have to discuss what should be this value, how this value should be defined. Because
yeah, that's actually my point. So we should discuss it. So because
you should discover the NUMA topology on the kubelet start, and thus you should decide what probably the best option that you can set under the groups.
Yes, something like that. We should define these NUMA groups somehow, and maybe have an option to override this default definition. But you know, forcing admins to define them always if they want to use this feature, it's kind of I don't know, not very user friendly from my point of view.
First of all, you do not need really to define it for feature. Like if you want to use the feature, you can just do not define it, and the memory manager will use the default behavior to set preferred. And what exactly we will have under the alpha, because like Kevin proposed, it can be problematic to understand all logic because the preferred was not intended for this purpose. So we just dropped it under the alpha, and we can like discuss again what will be the best and how we can introduce it in the beta. So yeah, it's our plan.
Anyway, I would propose to discuss it further. So let's go to the next slide, but that's point should be like should be discussed.
Sure.
Thank you.
Thanks for raising that. With respect to the cap, I think the introductory sections are ready for review, and I was wondering if I just was wondering, it is nothing beyond that. If, for example, only the introductory sections could be reviewed first before the whole review. So it is, I think, it is a question about best practices, how to carry out the review, and maybe Derek.
Yeah. So if you mark the KEP as provisional, and there was an update recently to the KEP template that let you identify sections of a KEP that might be not agreed upon. Like I forget the language we had for that. Then we can avoid. We can follow a more merge and iterate approach without saying that we've reached full consensus. And so that's one option you can take if you have a clear section of the KEP that you're comfortable with, and then we identify, just look up the KEP template in and you'll see a section as how to identify unresolved or areas where we lack consensus yet. If we just follow that, then that's fine as well.
Oh, so that's great, because this KEP is in fact lengthy, so it would easy the process of reviewing by just focusing on introductory and individual sections. Okay, so that's great. And yeah, we just wanted to ask because in fact it is my first KEP, and I don't really know the details and what would be the checklist to follow and approach the review. And because Derek, you agreed to review the KEP, and I was thinking if we can add you to the reviewers section.
Yeah, just go ahead and add. And I will, if you can update the parts of the KEP you feel comfortable with and mark the parts that you think are safe to be ignored at the moment, that would be helpful.
Okay, that's great. And if there are any other reviewers obligatory in the, because usually there are two approvals required, yes, or I'm not.
Not so much. Like typically we just try to find like a primary shepherd. I think in this space though, like I'd love to grow reviewers, and so I don't want to speak for Kevin here, but if Kevin wanted to,
I'm happy. I was just going to volunteer actually to be like at least the first pass reviewer to kind of filter it before you dig yourself in. Yeah.
Oh, that's great.
So I think if you just want to make Kevin and myself reviewers, that's good, and I trust where Kevin's perspective is coming from based on the work he's had here.
Okay, that's great. So we'll proceed with this process and update KEP and so on. Okay, so I think it's all. So it's the last slide, and yeah, many thanks for your for this session.
So big thank you for folks coming this morning. We'll chat again at 1. I think for myself, I want to take one final pass on the pod level proposal, but I feel like we're iterating towards a consensus of that seems like a good thing to do. And I think, Kevin, your proposal on device manager enhancements, I think I haven't heard any wide disagreement on it. It seemed like a good thing to do for me as well. And so hopefully folks are feeling like our meeting at a higher cadence is helping us reach better outcomes. So for those of you who are going to join at 1, I'll see you at 1 Eastern in SIG Node. Bye all.
Thanks, buddy.
Thanks.
Thanks, bye.
Guys.